welcome to Programming for Fun with Scratch. This is episode 5. My name is Deeth Elza. I'm a digital services technician with the Richmond Public Library. And today we're going to build an arena game, and then we're going to look at the music extension for Scratch, which lets us write music using notes. Alright, so let's take a look. Here's our first Scratch project, and as usual, all of the things we're going to look at, the URLs are linked to in the description below the video. This one is called Arena Game, and it's a fully working written game that I want to go through with you and then show you some places where you might want to take a game like this and extend it in certain ways to make it your own. So in this game, you have the character that is who is you, basically, and you have to avoid the wolf and pick up the coins, and it's tough because while you move a little bit faster than the wolf always is making a direct line towards you, and you have to move around the screen a lot to get the coins. If you get 10 coins, you win the game. If the wolf catches you 3 times, you lose the game. I'm not doing too well. So, you probably get the idea here. I only have 1 life left. I need, oh, that's it. Okay. Anyways, you get the point. So, let's look at the game. So here we have our when green flag clicked block for the hero character. And the hero character is using a standard sprite from Scratch. So that is here. It's the Avery walking sprite. And the wolf is actually from another project by somebody else. So if we go here, we can see the wolf sprite is by Wolf Fox, and their project is here. And what's interesting is you can go into any project in Scratch, and if you see a sprite or a script or something that you like, down here at the bottom you have something called a backpack. And so you can take a sprite from any project, put it in a backpack, one of your own or somebody else's, and then in your project you can drag that back in. So your backpack stays with you between projects, and that's pretty cool. Make sure that if you do that, that you include a credit to the person whose project you got it from in the credits portion of your project. All right, so I got a wolf sprite from Wolf Fox. The coin, I think I drew that, or I got it from. This is a game that I've implemented now in 4 different languages. So it started off, I think, for the Pico 8 development environment, which simulates an 8-bit computer. Then I built it in Scratch, and I've done it in JavaScript and Python as well for the Code Club workshops here at the library. So we've got the hero, we've got a wolf, we've got a coin, and then we have 2 sprites that are just game over and you win, which we show at the end of the game, depending how the game ends. Alright, so the hero is where most of the action, most of the code is. So when the green flag is clicked, we call reset to set everything up, and then loop forever, as is standard in a game. And every time we loop, we do an animation tick, and we've got a lot of custom blocks here. We looked at custom blocks more in depth last episode, but we use them extensively to organize the code in this game. So animation tick, which is basically to keep all of the sprites animating at the same speed. If you just, for instance, went in and said, next timer or next costume on each time through the loop, they would animate much too fast, and you wouldn't even be able to see it really. And if we want to be able to change how fast they animate, we want to keep that in one place. So to do that, we're using an animation tick block defined over here, and it just uses the built-in scratch timer to make sure that we're not going too fast, and then it broadcasts next costume to all of the sprites, and the sprite can then just use the next costume block. That way they all stay in sync. Now we can change the timing in one place and they will still stay in sync. So that's kind of nice. In our forever loop, so we do the animation tick, and then we say if we are not game over equals 1. So if the game is not over, keep going. If the game is over, this means it won't do anything, but the sprites will keep animating. So if the game is not over, move the player. So that's a custom block down here. If the hero sprite is which is the sprite we're on, if it's touching the wolf, then call the collide with the enemy block. If it's touching the coin, call the collide with coin block. These are not if else. You could be touching both the wolf and the coin, and that would work. Okay, so the first custom block is reset. We just set our size. Every sprite is much larger than what we need for this game, so we set it down to 20%, or 1/5 of its normal size. We set rotation style to left, right, and that means when we turn, the sprite just flips like that. And it doesn't rotate around, doesn't spin around. Otherwise, if we turned 180 degrees to face the other direction, the sprite would actually be upside down because it would rotate around 180 degrees instead of just turning the way we want it. We default the speed to be 3, lives to be 3, the score to 0, the game over to 0. And lives and score, we have those down here in our variables, and we have them checked so that we can see on the screen how many lives and what our score is. So if the score gets to 10, we win. If the lives get to 0, we lose. Speed is so we can tweak the game to make it more difficult or easy if needed. And game over, we're treating that as a Boolean, but we don't have Boolean variables. So game over is 0 would be false and 1 would be true. You can see that in our loop. If game over is not equal to 1, so if game over is not true, it's false, so we would keep going. We could just say if game over equals 0, that would also work. Maybe a little simpler. Okay, we start off in the center, 0, 0. We point in direction 90, so we're pointing to the right. Negative 90 would be pointing to the left. And then we broadcast new enemy and new coin. And so we'll see on those sprites where those are implemented. We already looked at animation tick. Move player is the next custom block, and one of the longest. But what it's doing is just checking if you're pressing any of the arrow keys. So if the right arrow key, left arrow key, up arrow key, or down arrow keys. And all that does is changes your X or Y position by the speed that you're going at, or negative of the speed if you're going left or up. And for the right and left arrow keys, it makes sure you're facing in the direction up and down. Don't change the direction you're facing, but left and right do. And then we have at the end of it, if on edge bounce, you don't run off the screen. Okay, that's all fairly straightforward, I hope. We handle these arrow keys in pretty much every game we've done. So if you have any confusion about that, you can look at the code, or you can go back and look at any of our earlier games where we kind of step through this more step by step. So what's left? We have collide enemy and collide coin. So collide enemy, this is what we call here if we're touching the wolf. We change lives by -1, so lives go down. We play a sound, maybe not the best wolf biting you sound. We can always change that. And just pull this onto the screen a little more. If lives are less than 1, so if lives get to 0, or if somehow it goes negative before we get to this block, and incidentally that is why I have less than 1 rather than if lives equal to 0. Sometimes if you use equals, something will happen, get hit by 2 wolves somehow or whatever, and your lives go to -1, then we would not ever end the game. That would be a bug. So here I have if lives are less than 1. So if it's 0, if it's -1, anything that happens, even if something crazy and unexpected happens, as long as we're below 1, we're going to end the game. So we would, if lives are less than 1, set game over to 1, and that will stop the game up here, and broadcast game over. And we'll see that when we get over to the game over sprite, that's what triggers it to show itself. Otherwise, if the enemy hits you, we presume that you fight back against the wolf, but it costs you 1 life, or maybe we should make lives health instead. It costs you 1 health. And in any case, your health goes down, but the wolf goes away, and a new wolf enters the scene, enters the arena in a random location. So we will broadcast new enemy to get that new wolf coming. Otherwise, the wolf would be right on you, and you would immediately lose your other lives. All right. So that's the collide enemy. Collide coin is very similar, but instead of reducing your lives, it increases your coins, your score. Sorry. It plays a pickup sound, which is a little better than the wolf crashing into you. If your score is above 9, again, here we have a situation where we want to check if it's greater than 9 rather than saying equal to 10. Because if somehow something happened, maybe we change the game so you can pick up multiple coins, and your score went to 11, it wouldn't end the game if we use this equal to 10. So score greater than 9 will end the game. We set game over to 1, so that's true now, and we broadcast you win. Otherwise, if your score is not greater than 9, we broadcast new coin and wait. And we'll look at why this is broadcast and wait for both of these rather than just broadcast when we get to the coin and wolf sprites. All right, so hopefully all of that is relatively clear. And let's take a look at the wolf now. So the wolf has a when green flag clicked. I did not make it have its own reset block because it's a little simpler here. It just sets its speed to 2, so just a little less than the speed of the hero, which is, if you remember, is 3, and set size to 20% because again the wolf sprite is bigger than what we need, and we set the rotation style to left, right, and we show the wolf because if the game is over, we hide it. Okay, so our forever loop. If the X position of the hero, X is left, right, is less than the X position of the wolf, then point in direction -90, point facing left, and change X by negative speed, so move to the left. Otherwise, point direction 90, face to the right, and change direction by speed, move to the right. If the Y position of the hero is less than the Y position of the wolf, then change the wolf's Y position to be negative speed, else change Y position to be speed. So basically this just means that the wolf is always running towards the player. And then we have some event handlers. When I receive the you win or the game over messages, hide the sprite. When I receive next costume, use the next costume block, so that keeps the animation in sync. And when I receive new enemy, which I remember I do first thing in the game, but also every time the wolf scores a hit on the player, go to a random position, and then repeat until not touching hero, go to a random position. Now why do we call go to random position twice? Well, if we go to a random position on the screen, it could be anywhere. It could be off in the corner, somewhere, but it could also be already overlapping with the player, in which case we'd instantly get another hit on the player, and that wouldn't really be fair. So what we do is we move to a random position, but then if we are touching the hero, if we're not touching the hero, we do nothing. But if we are touching the hero, then we're going to go to a random, not touching here, repeat until not touching here. So we will go to a random position again. So we'll keep going to a random position until we're not touching the hero, and then we stop. And the reason back here on the hero, why we call broadcast new enemy and wait, is because if we didn't have that wait, we might keep going through our loop, moving and hit the wolf while it's still trying to figure out where to be. So we just want to make sure we wait until the wolf picks a position that is not overlapping with the character, and then we're good to go. All right. Now the coin, it's pretty simple. When I receive next costume, use the next costume block. When green flag is clicked, set it aside to 400%, because unlike the other sprites, the coin sprite was too small, so we make it much bigger, whereas the other sprites we're making smaller. We show the coin because we hide it when the game is over or you win. And then the only other thing is when we receive new coin, this is just like the code we had for the wolf. Go to a random position, repeat until we're not touching the hero, go to a random position. We can't just have the repeat until, because we might not call that first. We might not call it at all, go to a random position and still be in the same place. Shouldn't, because we did just collide with the hero, but just in case, it's better to write your code to be safer than not. Okay, then we have game over. Super easy. When the green flag is clicked, we set the size of the sprite and we hide. When we receive game over, we show. You win is just like that. Hide, set the size of the sprite. When we receive you win, show the sprite. The only other piece of this that I kind of wanted to go over is the stage, which has no scripts, but the backdrop. So how did we get this backdrop? This is not a standard Scratch backdrop, and I didn't get it from another project, and I didn't draw it myself really, but I did modify it a little bit. So if you can actually see the costume is Beach Malibu. So let's go here, and we see here is Beach Malibu. Now that's not the same as what we've got here. How do we do that? Pretty simple. We've got the pointer, so we can select just this lower part. What is that doing? Why it's blurry in there. I think that's not doing what I want it to do. So I can select here. I can actually, I think if we convert to vector, I have a better select tool. Maybe. No. I just need to get it right. In any case, let's try this one more time. So I'm going to select this whole lower half. There. And now I'm going to copy that. I will flip it vertical. Oh, I have to also paste it. Copy and then paste it. So otherwise I'm selecting it and moving it. So I flipped it vertical. And now, because the kind of lines up a little too much, I'll flip horizontal. And now there's less of a discernible, it doesn't look quite as copied as it did. I can, there's a little line in between, but that's basically how I made that sprite, or that backdrop. So if you look here, you can see like this dot here is repeated. It's because it's flipped and reversed, but that gives me a nice kind of sandy background for the arena. And that is essentially how the arena game works now. So what can we do with this? Now that we have a working game and we understand how the pieces fit together, what would be next with this? So we can certainly customize the sprites more. So I've got the Avery sprite and the wolf sprite. The coin sprite doesn't look very good. We could do better with that probably. We might want, Avery looks like she's kind of walking casually because it is a walking sprite. We might want to find a sprite or make a sprite where they're actually running because they're trying to avoid this wolf chasing after them. We can tweak the speeds, maybe give the wolf a little bit more of an edge or a little less if it's too hard. Right now it's pretty hard to avoid the wolf because the wolf is always running straight at you. We could add obstacles. That would make the wolf code a lot more complicated because we would have to add pathfinding to get around the obstacles, but it would give the hero a little bit more maneuverability to distract the wolf and hide. Where the wolf and coins start, so right now we just drop them in a random place that's not directly on the player. We could say that coins start near the edges because they're being thrown from the crowd outside the arena. We could say the wolf always starts off on the left because that's where the gate is that the wolf is released from. That might be something we could do. We could add more types of enemies. You could start off fighting the wolf, and if you make it long enough, then you could fight a bear or a warrior or something. So we could have alternative enemies and not just the wolf all the time. We could have you win or be able to buy weapons and armor and things, and maybe extra, so maybe your health could go back up, or you could fight the wolf off more effectively and not have your health go down every time. Start making it into more of a closer to like a role-playing game, and once you do that, you could add more locations and the ability to explore and find out things. You could have kind of like in our platformer game where we had multiple levels. We could have gates that open up after you got to a certain number of points, and you could escape through and get to other arenas or other rooms or corridors or whatever, and make it more of an adventure game. And you could add background music, some like stirring theme music to play while you're running from the wolf, trying to pick up all these coins. And that's what we're going to actually look at next. So if you look down here on the left, lower left, there's this blue button, and when you click that, it pulls up all of the extensions for Scratch. And the first one is music. So that's the one we will be looking at in the next project. So I'm going to just click on over to that. The link for you is in below the video. And this project is kind of work in progress. Once we're happy with it, we can copy these sprites over into the Arena project and have the music playing in the background. For now, I'm not quite happy with the music yet, but let's take a look at what we've got. So, what is all of this? So we've got a cello, a piano. I know it looks like an electric guitar, but there wasn't a cello sprite. We've got an organ, looks like, and a bass, and some drums. So let's see. Let's just play the cello part. Okay, so that was less than I was expecting. Oh, there we go. Okay. So what we have are 3 measures, and measure 3 is actually blank right now. I'm not sure why, but we can fill it. Each measure is 4 beats. So here we have half a beat, 1 beat, quarter of a beat, quarter of a beat, quarter of a beat, quarter of a beat, half a beat, quarter, quarter, and that should add up to 4. Measure 2 is broken down a little differently, but again, should measure to 4 beats. So what we do is we change to the instrument we like, set the tempo, and then we play these measures. And the measure is just a way to break this up, so it's not one big long thing. And also we can reuse. So we play measure 1, measure 2, then measure 3, then measure 1 again. So I'm going to do something really simple for measure 3, which is to take measure 2 and just reverse it. I am not a particularly good musician. I'm learning to play the ukulele a little bit, but if you know music, you'll probably be able to do a lot better than I do with this. But I want to show you how to access this. So again, we just went down here and you clicked on music to add the music extension, and that gives us these blocks. We've looked at extensions before. We've used the pen extension in the past. So each time you add an extension, it adds more blocks down here on the left. So we have play drums with a bunch of different drums we can play. Rests, to insert a little bit of silence between notes. Play note, and it gives you a number and then for how many beats. So 0.25 is a quarter beat. And when you click on the number, it shows you a nice little keyboard here. So 60, the default is this middle C. And we can go down octaves, and we can go up octaves. And of course we can choose other notes besides C. And so whatever we eventually choose will be here in that. It just becomes converted to a number. We can set the different instruments. And so that's an electric piano, organ, guitar. Some of them sound more like what they say than others. I don't even know what this is. Anyways, we have lots of different instruments. We can set the tempo, the speed that it's being played at, and we can also change the tempo by a certain amount, or we can read back the tempo with this reporter block. So that gives us a lot of flexibility to make music. We have lots of different instruments, lots of different drums, lots of different notes we can play for different lengths of time. We can insert rests. So now that we actually have an M3, yeah, measure 3, let's hear what it sounds like now. Okay, so maybe not the greatest music in the world, but you can see how, if you wanted to encode the Mario theme or the Zelda theme or something, and you can find the notes for that, or if you're good at music and you can hear the notes for that, you can put that right into here like that, or make up your own soon-to-be famous music theme song to put behind the arena music. Now we also have some other pieces here, and they're organized the same way. And they also are missing measure 3, which I thought I had done. Okay. In any case, in this one I'm going to skip measure 3 and play measure 2 twice. And these are based on the same notes, played for different lengths of time. And so we could have this be piano, and so this is going to be similar to what is being played on the cello, but instead of playing a note, I think it's in a different octave and played for a shorter length of time, but repeated instead of played. So instead of played for half a beat, it might play that note for a quarter beat and then another quarter beat. So you get a little bit different effect. Then we've got the bass, which does something similar, but takes those notes and plays them for longer, and then drops some of the notes because it doesn't have room to play all of them in the same measure. So I'm going to do this, the trick I did with the cello. So duplicate this here. Just reverse measure 2 as measure 3. Okay, and then we've got the drums. Now the drums didn't quite, you can't do quite the same thing because it doesn't have notes the way the instruments do. We just have different drums. And where is, okay, so I didn't have measure 3 for any of these. So I'm gonna do same thing here where I have 2 copies of measure 2. Now if that does sound a little similar, because for each note in the cello part, I assigned a different drum to it and the same length of time. So I just converted the notes into different drums. So we have bass drum for when it's playing C, I think, and snare drum matches up to a note in their bass, conga drum. So all of these drums match up to different notes that are being played by the cello. Hope that makes sense. Now, what happens when we put it all together? So this will play all four instruments, hopefully, in sync. Okay, it's not going to win any music awards, but we've got a lot of instruments playing together. And you can have a lot of fun playing with this. You can experiment. Again, if you actually know how to play an instrument, you're going to have a huge advantage on this over me. And but you can also look up chip tunes and other tunes on the internet and find an actual tune to put in here. Again, make sure you add the credits to your credit part of the project on the project page. And then once you've got all of this working and you've got your tune the way you like it, you can then take these instruments and copy them into your backpack and then load them from your backpack into the arena game. So you can tweak the arena game and make it your own and add sprites, you can add more levels, you can add more monsters or more enemies, you can add music, all sorts of things you can do. Once you have a working game, you can take it in all sorts of different directions. So that's why I've kind of focused in this series on helping you get a small, simple working game in a variety of different types of games. So if you're trying to make a platformer, or the arena game is kind of like a top-down scroller, or a story game, whatever type of game you want to make, we can start you off with a working, simple game, and from there you can keep adding and make it more complex and more rich and more varied. But having something that you can actually play to begin with can be invaluable. Now, with this music, what could we do from here? What could we add to make the music better? We could certainly make it more dramatic. Start by having somebody who knows music putting it. You could also, you don't have to do this to make your background music. I wanted to show you how the note blocks work, how the music extension works, but you could, in regular Scratch, in the sounds block, where's my mouse? There it is. In the sounds block, you can play a sound, and those sounds can be, you could upload a sound from your computer. So you could take a sound that you have, or you could go to some place like Open Game Art, and they have, you can browse here, you can get art for sprites, you can get textures for backgrounds, you can get sound effects, so maybe we could find something better for the wolf fighting with the hero, and there's also music, and so you can find a piece of music you like and download it. These are all freely available on Open Game Art, and there are other sites, but I like this one a lot. Again, the link to this will be in the description. Once you have a piece of music you like, you can upload it into your Scratch project, into a sprite, and then just use the play button to play it and have background music that way. So a lot easier than creating it note by note, but Scratch does give you this flexibility. If you want to make multi-instrumental sounds note by note, then you have that freedom to do that. Now, one thing that I couldn't do here that I was having trouble with is if I wanted to have like a guitar or a ukulele, something that plays chords, even a piano, there's no way to do that here. This is all plays a note, and then a note, and then a note, and then a note. There's no way to say play these four notes at the same time. So I looked around, and there was an old project on Scratch that showed how to do that by having an instrument that made clones of itself that played all of the other notes. And I wanted to see if I could do that without making clones. And so I got to this playing chords project, which has a lot of blocks, but they're mostly very similar and they're mostly very short. So I'm going to take you through that. Again, link is in the description. So here, when the green flag is clicked, we set instrument to be guitar in this case. I'm actually trying to make a ukulele, but there's no ukulele instrument here. And set tempo to 60 as we did before, then play. And so, where's play? Play is here. Play just says play bar 1, bar 2, bar 1, bar 2, bar 1, bar 3. And each bar is defined down here. So each bar is 4 strums. So roughly like a measure was, I think. Is that right? No, probably shorter. Anyways, so we strum here, bar 1 we strum C, G, A minor, F. Bar 2 we strum C, G, A minor, D. In bar 3 we strum C, G, A minor, G. Just slight variations in those, as there would be in a lot of pop songs. This song is actually based on I'm Yours by Jason Mraz, although it's not completely accurate. And so where do we have strum? So strum is over here. So we have a couple things. We have these strum messages, receiving strum messages, but we also have strum as blocks, as custom blocks, and that's what these are calling. You can tell by the color, these are calling the custom blocks. So we have strum G, just repeats 4 times playing this chord, and the chord is done as if it was tablature. So what it's telling you is what fret each finger is pressing a chord down in. So a ukulele, the strings go from the top down, C, G, E, and A. So 0 is no finger. That's an open string. And then the 2nd fret, 3rd fret, 2nd fret. So that's a G chord on a ukulele. So we repeat that 4 times, each time playing for a quarter of a beat. So yeah, this will be 1 beat. And so yes, this would be the same. A bar here is the same as what we were calling a measure in the theme music. I'm not actually sure which one is correct or if both are correct. I should look that up. So, and if we were doing this for a guitar, we would want to have 6 places to put note fingering. If it were a piano, we might even need as many as 10, because you could play with all 10 fingers. So chord is going to mean different things on different instruments. On a ukulele, there are only 4 strings, which is part of why I wanted to go with it, and also because I actually play ukulele a little bit. And then all of the strums are pretty much like this. So we're strumming G, we're just going to play a G chord 4 times. Strumming F, we play an F chord 4 times. There could be a lot of variations here. We might have something where we strum A minor twice and F twice, something like that. But we're going for simpler songs. Now we do have a couple of holds. So when we hold, we play a chord and then don't immediately play another chord. So we're playing for a full beat, we just strum once. And so we have a couple of holds and then another strum. So all the strums and holds are the same as each other. Just which fingers are pressing which strings changes. And the timing a little bit. All right, so all of those are calling play chord. Now, play chord is where we're going to call these events here. And so this is how we got away from having to make clones. We're not making any clones of the ukulele sprite to play a bunch of notes simultaneously. We're actually using messages to play them simultaneously, or as you'll see, just slightly less than simultaneously, because as you strum, your finger takes a small amount of time to go from one string to the next, and so we actually add in a little bit of a delay. On a piano, you might want to take that delay out because you could push all your fingers down at the same time, or you might want to have really small delays, maybe little random delays, because your fingers aren't really going to hit at exactly the same time. So you can have a little bit of offset to make it sound more human and realistic. That's up to you. That could be something you change, and again, you could even have that change here. You could have it based on the tempo, so that when you play faster, these delays get less, or you could have different types of strums. That's one of the things I'll talk about in a minute, but different types of strums are going to have different delays between all of these. So play chord. So we're playing the G string, the C string, the E string, and the A string for a number of beats. And so this is very much like tablature notation. So we're going to set those as variables. So G, C, E, and A are set to the G, C, E, and A we just passed through. Beats is set to the beats we just passed through, and that is so we can read them later in these event handlers, because we can't pass those values when we broadcast. So then we broadcast strum G, C, E, and A, and on A we broadcast and wait, and that's going to keep it from starting to play the next chord before the first chord is finished. So because it's a computer, even though we're calling these one after another, we're calling broadcast without waiting, it's going to go very fast, and it's going to sound to a listener as if they're all playing at the same time, except that we are adding a little bit of delay in here. So as we go down the strings, so G is the top string, C comes after that, then E, and then A. As we go down the strings, we add a slightly more delay, just to make it sound like you are plucking one string and then moving to the next as you strum. And then we call play note, and that is just our music extension again of play note for a certain number of beats. Now here we're playing note of the G that we just set plus 43, and the reason for that is because the G 43 is, if we click, if we take this out, if we click on 43, that is G. So if we pass 0 in, it just plays G. So an open string will play a G. And then we add whatever fret we move up is going to, so whatever we pass for the G will move us up the scale, up the keyboard here. And so just like moving up the frets on the ukulele. So that what this means is we can pass in just what fret our finger is in, and by adding 43, it'll play the right note for the G string. Each string has a little bit different one, because we want 0 on the C string to play a C. We want 0 on the E string to play an E. So we have a little bit different offsets for each one of them. And one of the ways we could extend this is, instead of passing in 43, we could pass in different numbers based on what octave we want to play in. So we could actually change the octave of the instrument, move it to be higher, a higher C or a lower C, a higher G or a lower G as the bass, by factoring that out into its own variable. And we can change the variable and have all of these match. So that's one possible extension to this chord playing. So what does this sound like? So we've got a little tune here, and I think we've stepped through all of the pieces. Yeah, that's. Yeah, so that's what we've got so far, and it doesn't sound particularly like a ukulele to me, but then again, it doesn't sound too much like a guitar to me either. It sounds more like a piano, um, but that's the limitations of um, these MIDI instruments in the browser, I think. But it still sounds like a tune, and it comes off pretty well. So you could certainly do something like that if you want your theme music or any music that you make for your games to have a chord structure. And we built in a chord structure that is just a strum down with slight delays between each string. There are lots and lots of chord ways to play a chord, and so you could build different chords in and kind of switch between them. And there are different ways to extend in that direction. I think that would be there's a lot of fun to be had exploring there. So you could factor out the octave, we talked about that. You could have different strumming patterns. You could even have it where instead of specifying these bars the way we do, maybe we could have type in text of like the notes A, B, C, or whatever notes. There's actually a system called ABC, which this is. It doesn't give any good examples of it on their main page. But yeah, here's an example. So ABC notation it's a simple notation for music. It's as simple as it can get, I guess. So this on the left, and it's kind of faint here, but basically it says G, A, B, C, D, E, D, B, D, E, D, B, and those letters and a few markers are converted into this musical notation on the right. You can also run this same text through a program that, instead of converting it into music notation for someone to sight read, can convert it into MIDI and play it, so you can hear it. So this is by typing in these letters, you're basically and some numbers for how long it's played for, and a few things to adapt up and down the scale. You can actually have that turned into listenable music, and you could in theory do something like that in Scratch, where you have some text with letters and numbers, and then convert that. You say, okay, if this has an A in it, play an A. That's something. It's a little hard to work with text in Scratch that way, but it can be done. So that would be a much more advanced project. And you could have a generic kind of measure block where which might be simpler, where you just pass in letters, and it says, well, if whatever letter this is, play that. Lots of places you can go with all of these projects. So I hope out of these 3 projects we've looked at today, it's given you lots of ideas for things you can do on your own, and ways that you can practice with Scratch and build your own projects and your own exciting tools and games. All right, so that is it for this week, and I hope to see you all again soon. Thanks for coming. Bye-bye.